Okay, so hello and welcome to this new live stream where we code a HTTP server for my personal website from scratch. Yesterday we were kind of struggling with trying to push articles onto the server because in the end we want some blog on there. And we're struggling to update the static file cache when such put requests were performed. So let's maybe revisit that. And where is the pen? Le pen. The pen is gone. It's there. Okay. So we have some. Sorry. Wrong scene. So we have some index, some page with hello there and some text. And on this page, we also want an overview of recent articles. So here is maybe article 1 with its preview. Here's article 2 with its preview. And we can also click on this. And we can also click on this to get to the article, which we have to generate. And these articles are typically in our file cache, which we might name a little bit different. They are located in the file cache, and when we go here and let's say we have a server and a client goes ahead and says put article 3, then we want to invalidate this index page this and recompute it when it's requested again. So this part here, we want to compute again. Exactly. How do we do this? So basically we've said we have some articles resource, and this resource we have this resource, and this resource is notified when something is put here. So this resource is notified when something gets put here, it puts it onto the disk, and now we have to update the file cache and invalidate it. But at the moment our file cache has no mechanism of doing so. So yeah, I'm now thinking about how we can actually do this. So we have the file cache that is referenced when we want to compute a response. And this cache, at the moment this cache uses an arena allocator, which it cannot when we want to evict it out of the cache. So maybe let's first change how the file cache works. What we could also do is say, make it more constricted and say we have an index page with yeah, we can make it a lot more easy actually when we don't make it this generic. So when we say we only have one index page and that index page references we still have to have these file caches. So let's say a file handle entry can have some status, status, cache status. File bucket. And it has some cache status. And it can be either cached, it can be invalid, and well, if it's invalid, then it has something in there, but okay, and not present, not cached. Okay. And we may also want to make this a hash map. The cache to actually be a hash table, which we could copy from our HTTP header map. shall we do that? So it can be either there or not. Let's visualize this. So let's say we have a file cache. And this file cache can have some entries. Don't know why I made it so big. So this can have maybe the index.html. And this is cached. So there's some pointer into the actual HTML cached. And our resource now, if this index.html depends on our articles resource and the articles resource gets updated, then we want to invalidate the cache. When we want to set this to invalid. And then now, the next time someone requests this, it gets updated. So let's first make this I mean, do we even delete anything out of this? I don't think we delete anything, so we could use the cache status. Maybe not. Not present. I don't know if we want these. Or bucket tag. We can have cached, we can have invalid. We can have not cached and not even present. So this is a bucket tag. And this may have a resource, article resource. Okay, so the file cache now becomes a hash map, and I guess we just copy this. Into the file cache. So this obviously is the key, the file name. The value is the content handle, and we have a tag, so this we don't need. We need these. which we put into here. We have some buckets we called file bucket, hash table M, hash table Q, hash table A. So let's go into the HTTP header map. Let's just copy them over and go into our file cache, paste them in here. Probably this will lead to some collisions, but let's leave it like this for now. I mean, we could put this into another file, which we just call hash.h. If not, define hash h. Define hash h and if, and go into the file cache, delete them, paste this in here. This hash also into the hash h. Now go into the HTTP header map. We can delete those. We can also delete this function. And we just include hash.h. I don't even think we need this one here. Okay. Go into the file cache. Also include hash h. So we have insert, get, delete, probably not. And so init get. So get gets your file bucket. Push with the file cache and the file name. Then should it be a string? I don't know. I mean, it could be a string. I mean, we just leave it like this for now. We insert into the file cache and we insert car star we insert with a key and the value. We build the static file cache. We can destroy the file cache. Okay. So this probably has to become a general purpose allocator. So inside the file cache, we now need probably something like this here. Clear, insert, and get. HTTP, no, it was the file cache. And in here, maybe just paste it for now. Okay. So initialize, we initialize the mutex, maybe this, set the length to 0, set these two. This is the file cache, this is the file cache. And we also have to initialize all of the buckets. So maybe empty. So this is then a file bucket, current bucket, file cache, buckets, hash m, hash table m, hash table m, current bucket, we set the tag to empty. This doesn't exist. Oh. Okay. So init destroy. So clear we can also take. File cache, but I don't think we need this, so destroy. Okay, insert. This is the file cache. The file cache. And we insert a car star. This is the file name. Size file name length. And then the car star content with a usize content length. Okay, so file bucket file cache length why is there even we already did that. So key is hashing the field name. So maybe you have to make this a string. string file name and string star content, because then it won't, otherwise it won't work with the hash function. Proposition file bucket. This is the file name, the content, the key is equal to the key. I think so. Key was a U32. So there's also a key associated with this U32 key. So it's either, if it's empty, so a tombstone shouldn't exist because we can't delete at the moment. Or maybe we can, so we shouldn't tombstone. Tombstone. No. Go back into the file cache file. So if it's a tombstone, if it's empty, and if it's all of the other things. So this is just the default. How do you do that again? Default, okay. So default is just that. This is the file bucket. File name dot content. File name content. I don't think we can do this. I think we have to keep it this way. We may have to redefine this in some way. So file name is equal to file name, so this is more like a mem copy. And here so let's say if the file name length is less than, so if it's greater than the file path length greater than or equal, return -1. Because then we can't copy it over. Because the file name, I guess we want to copy, but the content we won't. So content I'm not so sure, so let's just try. And see where it's going. So content is equal to content, probe bucket, content length is equal to content length, and the file name length. And probe bucket file name plus file name length is equal to the null terminator. Content. The key tag is equal to cached. Cached. So this obviously we have to replace header map with file cache. Temp bucket. This is the I mean, if we make it a string, then we have to allocate it. So we have to more or less our file cache should have an allocator. Yeah, this is the problem with strings. This is the problem with strings. So we can't do this. We'd have to copy it back. Another mem copy. I don't like this. I don't like this. Maybe we make it string. So the file name, when do we insert the file name? This is going to be, yeah, this is going to be destroyed. This memory is basically gone after the function call. So maybe we have to allocate something. We have some other way of referring to it. But I think we have to allocate. Yeah. Or we just do it like this. Yeah, but here we have to swap. So here we would have to mem copy again into the file name with the file name length. The content is equal to the content pointer, and the content length is equal to the content length. And here, this unfortunately now becomes So should we make a restriction on this here? That this has to be 256. I mean, it probably is 256. Note: the caller has to ensure that the file name buffer pointed to by file name is of size 256. So we remove all of this. Oh no. Content is equal to this. Content length is equal to temp bucket dot content length. And we have to mem copy into file name. Just file path length, more or less stern copy. Stern copy, stern copy this with the file path length. This is the temp bucket dot file name, file path length. Yeah, so this is the swap. And here we want basically just car star content and a U32 star content length. Result and result length. I mean, this can also be returned. So maybe make this an I32. Okay. So we hash so when we perform get, so this is a string. Yeah, this is a string. If file name length is greater than or equal to file path length, and this doesn't work. If this is, yeah, so now we have all of the different cases. So if this is cached, and string equal, no. So now it would be nice if this actually was a string. So it's more like a stir. So this is now the case. This is now a problem because we compare two different things. A string and this car thing. So invalid and not cached, uncached. So if it's uncached, then we have to go out to the disk. But we need a method to compare the string, the file name string, with this 256 car buffer. So key compare. I don't know if this is a good name. And it gets a string star a and a file name compare. A and gets car B, and the caller obviously has to ensure that B is of size file path length. So we go through for, so let's say car star A pointer is equal to A pointer, and car star B pointer is equal to, so B we can just use for int we could check. So if B plus A length is not equal to the null terminator, then we return -1. If that is the case, then we just do a mem compare, return mem compy and string A pointer also if A length is greater than file path length, we return false. Otherwise, we just compare the two with A length. So what we do here, if it is cached and we do a file name compy with this file name here and the probe bucket.file name, and this returns true. And then we put the result content and result length is equal to content length. Now we return the content length. If it is invalid and they are both they're true, they're both the same, we have to go and update the file based on the new resource. If it's uncached, go to the disk and fetch and fetch the content. If it's empty, return 0. Okay. If we have a tombstone, then we break. We just continue, okay. So also break here, break, break. Get probably has to acquire the mutex, and insert has to acquire the mutex as well. Not concerned with that right now. Let's see. So get uncached. Push. So we probably need some way of loading a file. So load file. And we have a car.style file name. I think it should have a load file, just gets a file bucket star bucket, and the file bucket should have a file descriptor. FD, and we try to open the FD with O read only. Bucket FD. If this thing is equal to -1, return -1. Close also the bucket FD. What do we have to do as well is now get the stat. So struct stat, file stat, or fstat, or whatever file stat. Then we we say stat if stat is equal to -1, return -1. Stat so the file path man stat, so it's fstat with the file descriptor. Oh no. No, this doesn't work. Because we would have to have it open the entire time. That doesn't work. So we have to open, we have to join the paths, which we have done down here. So we have some path buff, we copy the static folder, and then we copy the bucket file name, and this is the file path length. This is like just more like star and copy. No, this is mem copy. Then we try to open this path buff. We say i32 fd is equal to this. If the fd is equal to -1, then we return this. We want to open fstat the fd with the file stat, and we read into, now we have to allocate. Okay, so for this we also need the cache, or at least an allocator. GPA linked list allocator. Let's call it a linked list allocator. I don't know. Alloc. Allocate using the alloc size of car times filestat.st size. We say the car star content, so bucket content is equal to this. We read into the bucket content using the file descriptor and filestat.st size, and if it's not equal to filestat.st size, then we return -1. Let's say i16 red val is equal to 0, return -1 red vals equal to this. Go to close FD. We load the file. We read it into this, and we also set the bucket content length to file stat.st size. Okay, so this is the entire loading of the file using just the bucket and some linked list allocator. I mean, it could be an arena allocator. If we say that if we restrict the size of the resource, okay, I don't know. Maybe just use it like this for now. So this whole push business can be deleted. This is now not needed anymore. Okay. Okay. So in here, we can now say current. So we want to insert into the result, and we want to insert the file name, which is the D name, current entry D name, then the content, which is so this is something we have to handle here as well. So if bucket content is equal to car star -1 red vals equal to -1, go to close FD. So here we want to insert this with the content and the file stat.st size. Maybe we can utilize load file here. So if it doesn't fit, I mean, we only need the file path. We open this, and the result should be a car star content, and yeah, let's make this an I32. So now we could say something like load file here. So load file current entry dname, load file with some allocator and car star I32 content length is equal to this. If content length is equal to -1, then we want to insert so if the content length is equal to -1, we want to insert this with some bucket tag status. To the tag, to the status. Okay. So in here, we want to swap them. So pro bucket how does this work? So when this is empty, this is a fall through. Empty or tombstone, we just set the tag to the status. But here we swap them. I think this is it. Probe bucket. Temp bucket. Tag. Okay, so in here we insert, no. So we load the file, and if this is -1, we just, shall we insert empty? No. So we load the file, and return file stat.st size. No, red vals equal to file stat.st size. So if we have this, if it doesn't fit into the cache, we just say insert into the results, and then insert the current entry dname. I think we should probably separate the two. So go into our file cache. How do I call it in the HTTP header map? Initialized. And I have a second one, cache status, that is empty, and not cached, cached, and invalidated. invalidated. This also now has a cache status. So in our file cache, in insert, we say this is a cache status, empty, tombstone, and initialized. Say status is equal to status. Status is equal to status. Status is equal to status. Where do we put the tag? So in here we didn't, so we have an initialized one. Yeah, okay. And we say pro bucket tag is equal to initialized. Initialized. Okay. So get, I think you're now reducing this to the file bucket and initialized we set the result to equal to the pro bucket. And return 1. Okay. And now it expects the content with the content length. We just say this is null, or car star content the content with the content length and with null, with 0 and uncached. A return, we put in the content with the content length and cached, else we put in null 0 and uncached. Okay, so this seems a lot nicer. built the static cache. And now in our main.cpp, this is now a file bucket file with the file cache with the request target if also in the file cache we have to acquire the mutex. 1 second. Okay. So when inserting, we want to acquire mutex. Not init, but lock. And we also want to unlock it. Yeah, we also want to unlock it, which is here. And if this fails, we're probably in a bad spot. So if we can't init it, if we can't destroy it, if we can't lock it, just assert that this is 0. And here we also want to assert pthread mutex lock result. No. Oh. File cache guard is equal to 0. And in here, probably go to get exit, say assert pthread mutex unlock file cache guard is equal to 0. And here we say return the red val. I16 red val is equal to 0. Red val is equal to 1. Go to get exit. And here go to get exit. Okay. When we build the cache, we don't need that. Okay. Oh, if this is equal to 1, content length. So here we have to handle whether it's cached or not. So if get is less than or equal to 0, then we say init empty response result bad not found, and return. Else we do this here. We have to now switch on the file dot status, and this can either be a cached, this is the easiest case. This can be uncached, and it can be invalidated. So if it's cached, pretty easy, just do this. if it's not cached, I mean, concurrent reads should be fine in the cache, but not concurrent writes. Should we acquire the mutex every time? Writes to the file cache are very rare. Okay. If it's uncached, or should we put this into the file cache? Should we hide this? Should we hide this from the user? Probably. So get if this is initialized and this thing. We have to now switch on probe bucket status. If it's cached, we just do nothing. If it's uncached and invalidated, we have to do something else. So if it's uncached, we have to evict something. And we would need the size of the content. So we have to evict from the file cache with the size. So we have to we could make it in load file. Load file, we could copy this. Load file with evict. We'd have to now find an item in this thing that we can evict from the cache. We obviously have a file path. Okay, so now we have to go through the file path and find so we have to walk through this int I 0 I is less than hash table and this is the point where I say, shouldn't we make this all a linked list? Should we make this entire thing a linked list where it's yeah, we now have to find one that we can evict. So we just iterate over all of them and say file bucket, current bucket, file cache buckets or whatever, I don't know what it was called, and plus plus current bucket. If current bucket dot a content length is greater than or equal greater than or equal to filestat.st_size then we found it. We now have to evict this bucket, so we set if current bucket dot status is equal to is not equal to cached, continue. If this content length is greater than or equal to the st size, then we say current bucket say free using the alloc and we free this content and the current bucket status is equal to uncached. We can now use the alloc, allocate. So we can now try to do this here. So assert content is not equal to this. Assert not there should be enough size and enough room for the allocation by now. Then we read it and could not read entire file into cache. Set the red val to, no, it's 0 in the very beginning. Go to close FD, or more like break. We also set the bucket content, no, it's current bucket content length to file stat.st size. No. So this is the target bucket. Target bucket. Target bucket. Target bucket. And we set the target bucket status to cached. And here we should say so if we haven't found one, red val is equal to 1. Okay. So load file with evict the file cache, the target bucket, which is the probe bucket, and it needs an allocator, file cache. Oh no, we don't need an allocator. It should use the one from the file cache. So at this point we now have to load file with evict. If this is less than or equal to 0, assert cannot load file into cache. Load file with evict. And here we have to update the file. Update file. In case it got invalidated, we have to update it. That means it needs also an allocator. So this is the file bucket. Target bucket linked list allocator alloc if not target bucket resource. If we have no resource, we just return -1. So in our file cache, this resource can have a size. Resource length. Resource sterling. The question now is, how big is the resource? Get resource sterling of the target bucket resource. Resize resource sterling if resource sterling is now greater than target bucket resource stir length. If it's greater, then we want to free using the alloc and target bucket content. Or do we want to free the entire content? Or should we just always free the entire content and load it from disk again? I mean, we could just always free it. I'm not so sure right now. We also have to implement the linked list allocator. Where do we do load file? Load file is already not correct. Load file, we read into this. I mean, we have to do this. This is kind of a weakness of templates. Unsure how to do this. just forget about it right now. And if it isn't validated, we just don't care. Or what we can also do would be to use HTMX. That would be something that we could also do. Okay, so maybe we solve the templating by using HTMX, so we cannot update a file. Okay. Okay. Status cached. Load file with evict. So this is not a thing anymore. So if probe bucket status is equal to uncached, load file with evict. What do we do next? Yeah, so I suppose this should be somewhat okay now. So we have to load it. Let's see if we can get this somehow to compile. content file content length. Let's see what we got. Make HTTP server debug mode 1 TLS 0 CC client. Okay, so include hash. File cache. So get this is probably a string. W, what the fuck? File handle dot file size. File handle dot file size. Content length. Resource articles. Put article. Parse article preview. So this we don't have. Add subscriber. We don't need these. Articles. So we don't have these subscribers here anymore. Articles resource. Redefinition of bucket tag. Let's call it a file bucket tag. Redefinition. Okay. Then we put it into hash.h. So file cache. HTTP header map. Path buffer. articles. So this should be part of the file cache. Ooh, I think. Oh, so this uses articles, and articles uses. Okay. So maybe pull up that constant into mem. And in articles, include mem. Redefinition. Count define. Okay. So now we get a ton of errors. Memcomp p. Oh yeah. It wasn't memcopy. Was mem equal. So this is in file cache, uncached, get exit, get file cache, get exit. Temp bucket status. Case get exit. Get exit. Unlock. I don't know. Did you mean flock? What? Why doesn't that work? Sorry? Is there some syntax error? Okay. Result alloc. Hash file name. stir, maybe we call this a stir n hash. We would need to know this ahead of time. Yeah, this is kind of complicated. So we need to find the hash function doesn't really work here. So we can maybe fix this first, which is a linked list allocator alloc and a linked list allocator. Maybe we start and say list allocator.h. If not defined, linked list allocator. Fine. And struct linked list allocator. Probably has a head and a tail. Struct block. It probably has a void star start header and a usize length. This is a block star and a block star. And this also has void star allocate and takes the linked list allocator star with the size. Yeah, just a usize. And a file cache, you probably want to include linked list allocator.h. Okay, this also needs an init method. With a usize. And it probably also, no. No matching function to init. File cache memory. So this now becomes a linked list allocator. And here we just say, what was it, allocate. Allocate with the program memory. the file cache limit and say that this is the void star start header. Or we can say something like it needs some arena allocator first. So init the file cache memory. Okay. Handle request args. This now gets no. How do we access the file cache memory? We don't need this anymore. Oh yeah, okay. So file cache memory. And here we initialize the file cache using the file cache memory. We also initialize the resource. So no matching call to init. This now only has this. Articles dot cpp init doesn't have this. Doesn't need this. Doesn't need this. Preview put article. We don't. Yeah, it needs a guard probably right now. So it needs a guard. Resource guard. Only one should write into this at a time. So this has now a guard and an articles.cpp our init pthread mutex init result guard null equal to -1 return -1 if we also need a destroy. Articles also has a destroy now. Okay, load file. File cache. Load file. Star content. Star content. Max static files 281. Hash table M. .240. So this is a file bucket. Load file with evict. Load file. Don't have to provide it twice. Okay, star and copy. String.h. File name length. This is 163. File name length. What does star and copy return? Return I. So I16 length. Sort length greater than 0 plus length. No. This is a dir entry, so we can just say memcopy. I think this is easier. And here we can also just memcopy. Okay, so now the hash thing. So this is also a problem because this is now a linked list allocator. Becomes the alloc. Okay, now the string hash. The string hash. Star hash. Or more like star and hash. View size, max line. We have to get the Sterling So let's get memchar findchar value mem findchar. This is the pointer. Mem find character. So this is a car star pointer. This is the end pointer. And say value length. So this is the length. This is end pointer minus value. So if not end pointer if not end pointer, then we set end pointer to value plus length, end pointer minus value, and this is now the end pointer minus 1. I don't know if this is correct. Stir n hash and get. So we know that this is star n hash. In get we can just hash. Hash star n hash file path length. So this is 120. File cache. Min length is equal to let's say end pointer minus value bucket and file cache 93. No, 93. Just close the FD 84 bucket content. Same thing here. Okay, so there's no free in our linked list allocator. So void free linked list allocator. And we get an adder, void star adder. Use of undeclared file path. File name. Init. In articles. Resource. Assert. And return 0. Okay, so now we have to implement all of the functionality in the linked list allocator. Linked list allocator.h. And include linked list allocator.h. Which we won't do now. Undefined reference to, okay. Okay, this is what we will do tomorrow probably. Yep, so this is it for now. Call it a day. Thank you for watching. Have a nice weekend. No, not a nice weekend. Have a nice week. And bye.